Hello everybody, this is Uno at Uno Labs. Going to show you how to make a quick bridge rectifier out of alternator rectifier. And what I started with happens to be a Delco Remy, and I also used a Motorola over there. Now let me start with this. This is the bridge out of a Delco Remy. Pretty simple. This happens to be right here, and here is the bridge out of a Motorola. Right here and here, here and here is a rectifier, a diode. And on this little puppy, there happens to be right here, here, and here, but we'll remove the middle one. And I'll get into that in just a minute. I'm going to shut down and come back after I get this set up so we can start. Hello everybody, I'm back. Let's get started on this. This is just a piece of cutting board, HDPE, that I made a mounting block out of that this will go onto. You can use whatever, piece of wood, something simple. Like I said, this is a unit that I made out of a Motorola. It's a little bit different setup than the Delco, but it works. This bridge is made on a couple of brackets that fit the diameter of the alternator. Remy has it on a little cooling block, which is kind of neat. That's what we'll be using. So all this is for is converting AC to DC. They both have 6 diodes in them. And to people who don't know, alternators are AC generators, 3-phase, that they convert to DC, and this is what they use to convert to. Use it to convert it to is a bridge rectifier. To do this, take the alternator apart. You'll see this little block in there, just unbolts, a couple bolts and a couple wires, and you got it out. Like I said, there's 3 rectifiers total that show here, one on each side, so that's 6 total. Take the middle one out. This block will slide apart very easily. It just comes apart. I just broke the leers off that come around to these studs. Just eliminate the third one, you don't need it. Next, you need to find out which direction they're going. Diodes are directional. Get this set up here. You can see it. As I probe this, I'm going to put one on the heat sink on one side, and there's a reading. There'll be a reading on this one. But now if you just take the leads and put one over on the other block and use the one that was on the block, you'll get a reading that way too. But if you reverse these and do it the same way again, put that one there, you will not get a reading. Will be on the block, continuity, but nothing through the diode. If you take that and put it on the heat sink, bring it over, that's considered a good diode. And you're doing this either on a diode check, some meters have a diode check, or resistance. Resistance will work also on a VOM. So once you figure that out, you're pretty much home when you're using this little critter. Bridge rectifier, you need 4 contacts. And I'm going to zoom on in here a little bit. Now, the 4 connections is this connection here and this connection here, and this block which is insulated. There's an insulator in here which runs this, and then there's another block over here runs this way. This will be one connection, 2, 3, and 4. Alrighty. Now, these two middle ones will be your AC inputs. Just a regular AC power cord where it plugs in. Just strip it back like I did here, and you can connect them. Connect them right here. This will be your DC outputs. Once you get together, you can measure out what's positive, what's negative, but there'll be a positive and negative side. And that is the extent of a full bridge rectifier. It's that simple. Bolt that on. Here's my lugs for my connections. I will put one on like that and tighten it down. I got a nut underneath there. If you didn't catch that, that is in the block. That will tighten this bolt really well right here. These are driven into the plate, the HDPE. Now when I tighten this up, it'll be a nice tight connection. And that leaves me enough room right here on top for a connection, cable connection. And it is that simple. So that is a full bridge rectifier. Simple, easy to use. I do not know what it is capable of, what amperage you can pull through it. I'm going to send this to my good friend up here in Oregon. Everybody might know him on the forum as Daryl. So, and he's going to run it through the mill. He's needing one really bad, and I said I would set him up with something real quick and get it to him. And this is where that's going. So, thank you for watching. It's, like I said, very easy if you want to use a variac and be able to adjust your DC. This is what you need, and you can do it. So this is Uno. I thank you for watching. Good day. Hello again, this is Uno. I'm back again just to give this thing a little run before I put it away. Just so you know that it does work. I've set up a meter. Now I do have a, whoops, sorry about that there folks. I do have a small variac right here in the wall that I have it plugged into, and that's what I'm going to be adjusting. And I get this around here. Now, putting my probes on, like I said, the two big studs on either end, those will be your DC. My AC is hooked up right here, the two small wires in the middle. And I got my variac turned off. Now, I gotta get to this so I don't block the view. Well, let's change this around here. Let's go this way. Okay. As you can see, it's bouncing around, but I want to turn it up. Here's 7, 8, there's 13, 18 volts, 19 volts, 21, 31, 45 volts DC. So it does work. I'm only putting in 70 volts right there on my variac, and it's 70 volts out, 69.4. So it does work. So turn it back down and off. So there you go for a simple poor man's bridge rectifier. Thank you. Goodbye, all.